Alrighty, so for this first one, 12-ounce can of Coke contains this many grams of caffeine. Ooh, and they gave me the molecular formula. That may be useful. Determine the number of particles. So in the end, I have to have particles in my answer. Particles. And I start off with this many grams. So the only conversion that I know that has grams is the one that has grams and mole as a thing. And that is molar mass. Yay! So we have to find the molar mass of caffeine, which is carbon, and there's 8 carbons, hydrogen, and there's 10 hydrogens, oxygen, and there are, I forgot nitrogen, and there are 4 nitrogens, and oxygen, and there are 2 oxygens. Alright, so I have to find the molar mass of this whole compound, so I have to add up each and every single atom in this compound. I know that the mass of carbon, just one, is 12.011 grams per mole, right? But I have 8, so I'm going to multiply this number by 8 equals. So 12.011 times 8 is 96.088. Next one. I know that the mass of one hydrogen atom is 1.008 grams per mole, right? But I have 10, so I'm going to multiply this number by 10. And I know that that is going to give me, 10.08. Alright, next one. I have nitrogen. I know that the mass of one nitrogen atom is 14.007, but I have 4 atoms of nitrogen because of these little subscripts that you see up here. So I have to multiply 14.007 times 4, and that is equal to 56.028. Almost done. I just need oxygen. So oxygen, one atom, is 15.999, or not an atom, but yeah, an atom. And I have 2 molecules of oxygen, so I have to multiply 15.999 times 2, and that is equal to 31.998. Okay, so now I have the masses of every single part of this compound. But now I have to go and I have to add every single one. So I am going to add this amount, this one, and this one, all of them together. So 96.088 plus 10.08 plus 56.028 plus 31.998 is equal to, drumroll please, 194.194 grams per mole. Wow. So that's the molar mass of caffeine. So now that I know that there are 194.194 grams. I know that grams has to go on the bottom because it's at the top and I want to cancel it out, per 1 mole. Beautiful. That took a long time. So I have grams at the top, grams at the bottom. That cancels out. I still have moles, and I need particles. And I know that the only other conversion that gives me a mole and, let me move that, a mole and a particle conversion is 1 mole is equal to 6.022, or 2, times 10 to the, this always takes me forever, 23rd particles, or atoms, or molecules, or whatever the word may be. So I know that I have to put moles at the bottom to cancel out the moles at the top, and I know that I have to put particles at the top because that was what my answer has. So now I have effectively canceled out the moles. and I am only left with particles, which is what I wanted. So all that I have left to do is just do the math, multiply and divide. So I'm going to multiply 0.0345 times 6.02 times 10 to the 23rd. And then I'm going to divide that number by this bottom number because it's at the bottom, so I have to divide. So divided by 194.194. And that is equal to 1.07, rounded to the hundreds, times 10 to the 20th particles. And that is my answer. So I had to find my molar mass of this huge compound. I had to cancel out my units and just remember my conversions. This conversion and the molar mass conversion. Alright, cool. So next one. Laughing gas is dinitrogen monoxide. Ooh, look, this is bringing back our naming conventions for molecular compounds. So dinitrogen monoxide, di means two, so I'm going to have two nitrogens, dinitrogen. Monoxide, mono is one oxygen, and that's it. So dinitrogen monoxide is this right here. How many grams? Oh man, we are already starting with finding stuff. How many grams of dinitrogen monoxide are in 45 liters at STP? Okay, there's a lot of information here. So they're asking for grams, so my final answer has to have grams. And I start with 45.0 liters. And STP, because they said STP, I know that I can use 1 mole is equal to 22.4 liters. They gave me a lot of information there. Okay, so I'm going to start setting up. I have liters at the top. I need liters at the bottom. The one conversion that lets me put liters is this one. So for 22.4 liters are in 1 mole. So doing this, I have successfully canceled out my liters. And now I'm left with moles. And I have to get to grams. The only other one that has grams and moles are grams per mole. And you guessed it again, Mr. Shiny, the one that always likes to show up, is the molar mass. So the molar mass of this compound of N2O, dinitrogen monoxide, I have to calculate it. So nitrogen, oh, there it is. With nitrogen, I have 2 atoms of nitrogen because it has a little 2 subscript. And for oxygen, I just have 1. So now I have to go in and find my masses. I know that 1 atom of nitrogen is 14.007. And I have to multiply that by 2 because I have 2 nitrogen atoms. For oxygen, I know that that is a 15.999 mass, and I only have 1, so I don't need to multiply by anything. 14.007 times 2 is 28.014. So now I'm ready to find the total molar mass of that compound because I can just add these 2 numbers. So 28.014 plus 15.999 plus 15.999 is equal to 44.013. Whoop, not there. What am I doing? What am I doing? Is equal to 44.013 grams per mole. So I know that the molar mass of dinitrogen monoxide is 44.013 grams per mole. So now I can continue with the problem. If I have moles at the top, I need moles at the bottom to cancel out because my answer does not have moles in it. So I have to cancel it out. The one that I put on top is grams, specifically 44.013 grams. Okay, so let's recap. I have canceled out my liters. Now I have canceled out my moles, and all I have left is grams, which is what I wanted. So now I am ready to finally just do the math. So I'm going to multiply 45 times 44.013. I am doing that because those numbers are next to each other. And I'm going to divide all of that by this number at the bottom, 22.4. And that is equal to, drum roll, 88.42 grams. And that is that. So, always cross out the units that you don't need in your final answer, and then you're going to just do the math. Multiply if they're next to each other, divide if there is something at the bottom.